Children, I am Naresh from Pragati Vidyaniketan, Physics faculty. Yeah, for example, you are sitting in a dark room. Are you able to see the objects? Our answer is no. You are sitting in a, if the light is present, if you are sitting in that room, easily we can see the objects. In two cases we can observe. In first case light is absent, in second case light is present. The absence of light is said to be dark. When a light enter into your room, then only you are able to see the objects. Why? What happens to that? What is the light? Light is nothing but, light is a form of energy. It causes sensation of sight. When it is striking on your eye, it makes things visible. When a light falls on objects, it comes back, it rebounds back. That rebounding rays or reaches your eye, then only you are able to see the objects. Otherwise, we are not able to see the objects. So, in previous class, in 7th class and 8th class, in 7th class you have learned reflection of light. In 8th class also you got a reflection of light. In 9th class, refraction of light you got. So, in 7th and 8th, you have got what is the light, what is the reflection, what is the reflector, what is the plane mirror, how the image formation due to plane mirror. These all things you got. So first we have to learn what are the basics which are related to this topic. So what is the reflection? What is the reflection means? Reflection means, for example, you take one ball and make the ball throw towards the wall. When the ball hit the wall, automatically it comes back. The coming back is said to be rebounding back. So when a light falls on mirror, automatically you will get the reflection of light. What is the reflection of light? What is the reflection means? The light coming back from a boundary separating two media is said to be reflection of light, or rebounding of light is said to be reflection of light. Here this is the symbol of a mirror. Already you have learnt in 7th class. This is a symbol of mirror. So when from the object we are getting number of light rays, but for drawing ray diagram I am taking only one single ray. This ray, when the ray falls on mirror, it rebounds back. When a light falls on mirror, it rebounds back. This phenomenon is said to be reflection of light. So this ray is said to be incident ray. So this point where the incident ray incident on the mirror is said to be point of incidence. This is the rebounding ray, that is the reflector ray. So this is here we observe that this is the point of incidence, and this surface is said to be reflector. What is a reflector? The surface from which reflection takes place is called reflector. The surface from which reflection takes place is called reflector. So here, the third definition is regular reflection. If the surface has number of regularities, means if the surface is smooth, then the reflection from the surface is said to be regular reflection. For example, light ray incident on the mirror, it comes back. This is a regular reflection. So what is a regular reflection? What is a regular reflection means if the surface has a number of irregularities, when a light falls on that, then automatically that reflection is said to be irregular reflection. So here we observe a diagram. In this diagram, from this diagram we are going to learn a few definitions. One is the angle of incidence. What is the angle of incidence means? The angle made by the incident ray with the normal is said to be angle of incidence. What is the normal? This dotted line represents to us normal. This ON is called normal. This AO is called incident ray. This OB is called reflector ray. So the ray which is moving towards the mirror is said to be incident ray. The ray which is coming back from the mirror is said to be reflector ray. So the angle made by the incident ray with the normal is said to be angle of incidence. The angle made by the reflector ray with the normal is called angle of reflection. So here, what is the angle of glancing? the angle made by the reflected ray with the surface is called angle of glancing. It is represented by alpha. Here also the angle made by the incident ray with the surface is called angle of glancing. Angle of glancing. And if the mirror is absent, the light ray traveling in a straight path. We know that the light ray in a homogeneous medium, the path of the light is straight. So here if the mirror is absent, the path of the light is straight. So if the mirror is present, then here mirror is present. That's why the light comes back into the same medium from the mirror. So here the angle made by the reflected ray with the extended incident ray is called, this angle is called angle of deviation. This angle of deviation is represented with D. So we can write these two are vertical opposite angles. So if this angle is alpha, means glancing angle, here also angle becomes alpha. So we can write D equal to alpha plus alpha to alpha. Then here this is a straight line. This angle is a straight angle, that is a 180. So we can write angle of deviation is equal to 180 minus 2i. 180 minus 2i. Then next laws of reflection. This laws of reflection is very important in our 10th class. So what are the laws of reflection? The first law of reflection is, here this is angle of incidence, this is angle of reflection. The first law is angle of incidence is equal to angle of reflection. Angle of incidence is equal to angle of reflection. The second law of reflection is incident ray, reflected ray and normal all are lies on same plane. This is the second law. And what is the object? What is the object means the point of intersection of incident rays is said to be object. The point of intersection of incident rays is said to be object. For example, this is the mirror, this is the point object. Let me take, if this is incident ray, this is also another incident ray, this is normal, this is reflected ray, this is also reflected ray. So here this is the incident ray, this is incident. The point of intersection of incident rays is said to be object. Next, what is the image? The point of intersection of reflected rays is said to be image. So images are two types. One is the real image, another one is the virtual image. What is the real image? Images are two types. One is the real image, another one is the virtual image. What is the real image? Real image means the point of intersection of reflected rays is said to be real image, or the image which we can caught on the screen is said to be real image, or the image which we can obtain on the screen is said to be real image. What is the virtual image? The image which we cannot caught on the screen is said to be virtual image. The image which we cannot obtain on the screen is said to be virtual image. The point of intersection of extended. This is the reflected ray, this is the reflected ray. When we extend this backside, when we extend these two are intersecting here, this is said to be extended reflected rays. So the point of intersection of extended reflected rays is said to be virtual image. If the object is real, image is virtual. If the object is virtual, image is real. This is vice versa. Types of mirrors. There are two types of mirror. One is the plane mirror, another one is the spherical mirror. So already we got the information about plane mirror in 8th class, and now we are going to learn the information in this 10th class. Now we are going to learn the spherical mirrors. So today's topic is reflection of light at curved surfaces. So spherical mirrors are again classified into two. One is the concave mirror, other one is the convex mirror. So let me take, this is the sphere. This is the sphere, means sphere is nothing but a ball. It is made up of a glass. Now we are going to cut a small portion. We are taking a small portion from this sphere. It appears to like this. So this is the inward, this is the outward surfaces. So inward surface is said to be concave surface, outward surface is said to be convex surface. So bent inward, bent outward. So this is the concave mirror. So this is the, already we discussed that this is a sphere. If I painted this surface, when we separate from this sphere, it appears to like this. This is the concave mirror. Why I am saying this is a concave mirror means, in this concave mirror, concave surface acts as a reflected surface and convex is silvered. Next, convex surface, convex mirror. What is a convex mirror means? If the convex surface acts as a reflected surface and concave is silvered, concave is painted. So this mirror is said to be convex mirror, concave mirror and convex mirror. So these laws of reflections are applicable to these spherical mirrors also, concave mirror and convex mirror also. And what are the related terms? Pole. What is a pole means? It is a point on the middle of the surface. Is said to be pole. So pole is represented by P. And this small portion is taken from this sphere. So this is center. We know that the distance between any point on the sphere to center is called radius of curvature. Radius, already we know that. So here this small portion is cut from this hollow sphere. So that's why we are taking the center of this curved surface is as a center of this spherical surface, center of this hollow surface. So hollow sphere. So this is the center. What is the center of curvature? The center of the sphere of which the mirror is a part. That is called center of curvature. The distance between pole and distance between pole to center is called radius of curvature. What is the radius of curvature? The radius of the sphere of which the mirror is a part.
Activity: finding the normal to a curved surface. Take a small piece of rubber. Fix some pins in a straight line on it. All the pins will be perpendicular to the surface of the foam. They are the normal for any incident ray at their point of fixation and help in obtaining the reflected ray. Now, bend the rubber inwards. The pins representing the normal at their respective points of fixation tend to converge at a point. For a convex mirror, this point of convergence of the normals is called its center of curvature C. When the rubber is bent outwards, the pins representing the normal tend to diverge from each other, but they appear to emerge from a single point. For a concave mirror, this point is its center of curvature C. Note, the fact that a radius to a point on a circle is always perpendicular to the tangent passing through that point is used in finding the normal to the curved surface. Any line drawn from a point on a curved mirror to its center of curvature is the normal at that point. To better understand reflection of parallel incident rays by spherical mirrors, let us define some of the physical quantities. Pole. The geometrical center or midpoint of the mirror is called pole P. Principal axis. It is the horizontal line passing through the center of curvature C and pole P of the mirror. Radius of curvature R. It is the distance between pole P and the center of curvature C of the mirror. View the following animation.
How can we get a parallel beam of light? For our understanding, we have an activity in 10th class. So this is the thermocol box. These two are pins. These two are pins stuck on thermocol box. So this is the candle. We are the candle kept backside of the thermocol box. We are getting the image of two pins. Here the angle of diverging at the base increases. Then if the candle is moving away from the thermocol box, the angle of diverging decreasing gradually. Finally, the shadows of these two pins appears to us. These two are parallel. From this activity we can say that from the inferior object we are getting a parallel beam of light.
To know how parallel rays can be obtained when a powerful source of light is placed far away from the object. Find the focal point. Hold a concave mirror in a direction perpendicular to the sunlight. Take a small piece of paper and move it slowly in front of the mirror to find the spot where a brightest spot is obtained. Focus. The point where all the sun rays converge after getting reflected from the concave mirror is called the focus or the focal point F. Focal length. The distance between pole and the focus of a mirror is called the focal length F. Note, the radius of curvature is twice the focal length, that is R is equal to 2F. The image on screen shows the focal point of a convex mirror obtained by back extending the reflected rays. Let us learn about the characteristics of images formed from reflection by spherical surfaces through an activity. Now, let us know how the images are formed by concave and convex mirrors. Take two V-stands and place the concave and the convex mirrors on the stands. Light two candles of the same size and put them in front of the stands. Now, adjust the position of the candles such that they form clear images in the mirrors. When we observe the candle and its image on the concave mirror, we notice that the image is larger than the candle. Similarly, the image of the candle in front of the convex mirror is smaller than the size of the candle. Lab activity. Characteristics of an image from a spherical mirror. Click each tab to learn more. The aim of this activity is to observe the types of images and measuring their distances from the mirror. The required materials of this activity are a candle, paper, concave mirror, V-stand, measuring tape or meter scale. The procedure involves the following steps. Place the concave mirror on V-stand, a candle and a meter scale. Keep the candle at a distance of 10 cm from the mirror. Move the paper below the axis to find the position where a sharp image of the candle flame above the axis is formed. Note the distance of the image formed on the paper from the mirror. Repeat the procedure by keeping the candle at 20 cm, 30 cm, 40 cm, 50 cm, 60 cm, 70 cm, and 80 cm respectively. Note the observations accordingly. As part of our observation, Table 1 is used to note down the distance of the candle from the mirror, distance of the paper from the mirror, the size of the image and its inversion. Table 2 notes down the position of the image in and around the focal point and center of curvature and its other characteristics. From this activity, we have learned that the reflection of incident rays are not parallel to the axis of the spherical mirror from the above experiment. Let us find the characteristics of images formed from a spherical mirror with non-parallel incident rays using ray.
Rules for drawing ray diagram. So rule 1, for drawing ray diagrams compulsory we should learn these rules. One is this is the first rule. A ray which is parallel to the principal axis after reflection passes through the focus in a concave mirror. Here a ray which is parallel to the principal axis after reflection, the reflected ray appears to coming from the focus. Rule 2, a ray which is A ray which is passing through the focus after reflection parallel to the principal axis. A ray which appears to passing through the focus after reflection from the convex mirror parallel to the principal axis. So here we observe this is the pole, this is the focus, this is center of curvature. The distance between pole to focus is said to be focal length. So if the ray is parallel to the principal axis, after reflection, all the rays are intersecting at a point on the principal axis, that is said to be focus. The distance between pole to center is said to be radius of curvature. The line joining pole and center of curvature is said to be principal axis. So this is the principal axis. This is the principal axis. The next here the ray which is very close from the principal axis is said to be paraxial rays. The rays which are far from the principal axis is said to be marginal rays. These two are very, very important. Paraxial rays and marginal rays. And what is the rule 3? What is the rule 3? This is the concave mirror, pole, focus, center of curvature. So a ray which is passing through the center of curvature after reflection, the reflected ray also passes along the same path but in opposite direction. This is the convex mirror. So this is the pole, focus and center of curvature. A ray which appears to passing through the center of curvature after reflection. After reflection, the reflected ray passes along the same path but in opposite direction. These rules are very, very important. And rule 4. What is the rule 4? This is the concave mirror. This is the pole, focus and center of curvature. A ray which is passing through the principal axis after reflection, the reflected ray also passes along the same path but in opposite direction. So this is the convex mirror. So this is the pole, focus and center of curvature. So a ray which is appears to passes along the principal axis after reflection. The reflected ray also coming back along the same path. So these are all rules for drawing ray diagrams. So image formation due to plane mirror, image formation due to spherical mirrors. So image formation due to plane mirror. Already we discussed in 8th class. Image is a virtual image. The height of the image is equal to height of the object. Distance of the object is equal to distance of the image. What is the distance of the object? What is the distance of the image? Distance of the object means the distance between object to mirror is said to be object distance. The distance between image and mirror is said to be image distance. So distance of the object equal to distance of the image, and the height of the image is equal to height of the object. Image is a lateral inversion. Lateral inversion means if you raise your right hand, it appears to us that is the left hand. These characteristics of the image formation due to plane mirror you got in 8th class. So now we are going to learn what are the characteristics of the image formation due to concave mirror and convex mirror. First, concave mirror.
Ray diagrams. Now, let us learn about the ray diagrams in detail. Ray diagrams with concave mirror. Though it is not easy to construct the reflected angle for any arbitrary ray in a concave mirror, some easy ray construction can be considered. They are: a ray R1 starting from the tip of the object and parallel to the axis of the mirror passes through the focus F after reflection. A ray R2 starting from the tip of the flame and passing through the focus F of the mirror travels parallel to its axis after undergoing reflection. The intersection point of the rays R1 and R2 provide the point where the tip of the flame appears like an image. The principal axis itself can be considered as a ray normal to the surface of the mirror before and after undergoing reflection. A ray R3 starting from the tip of the object and passing through the center of curvature C will retrace its path in opposite direction. This is because of the fact that a radius and a tangent of a circle are always perpendicular. A ray starting from the tip of the object and meeting the mirror at pole P will have the principal axis as its normal to draw its reflected ray. If any two rays coming from the tip of the object intersect at point A, and any two rays coming from the base of the object intersect at B, both the points are at same distance from the mirror, the image formed is vertical and inverted.
Image formation due to concave mirror is depending on object from the mirror. So if the object is at infinity, from the infinity object we are getting a parallel beam of light, then image forms at focus. Image is real, image is inverted, image forms at focus, image is point size image. Already we have got through one activity this one, and case 2, object moves towards the mirror, image moves away from the mirror. So here if the object is beyond C, image forms between focus and center of curvature, image is real, image is inverted, image is diminished image. Case 3, if the object is at center of curvature, if at center of curvature, image also will get at a center of curvature. So image is the size of the image is equal to size of the object. Case 4, here the object lies between focus and center of curvature, then we are getting the image beyond center of curvature. So here image is enlarged image, image is real, image is inverted image. Inverted means that is a reverse image. And case 5, if the object is at focus, we are getting the image is enlarged image and forms at infinity. And case 6, if the object lies between pole and focus, then we are getting the image is inside the mirror, that image is virtual image, that image is erect image, the image is magnified. The image is magnified.
When the object is placed vertically above the axis beyond the center of curvature, the image formed is vertical. A perpendicular from the axis to point A provides the point which acts as the base of the image. This is because any ray starting from a point on the axis and traveling along it gets reflected along itself. For the case when the object is placed at a distance less than the focal length, the reflected rays R1 and R3 undergo divergence and the image is not formed. When the divergent rays R1 and R3 are back extended, they appear to emerge from a point inside the mirror. The image is visible in this case is erected and called the virtual image and not the real image. When the object is placed at the center of curvature, the image is formed at the same distance, which is of the same size and is inverted. Some rules to follow for drawing easy ray diagrams for a convex mirror are: Rule 1. A ray traveling parallel to axis on meeting the convex mirror will get reflected so as to appear emerging from the focal point F. Rule 2. A ray traveling along the direction of the focal point F will get reflected parallel to the principal axis. Rule 3. A ray traveling along the direction of the center of curvature C will retrace its path and would seem to appear from center of curvature C. After learning to draw ray diagrams to get the images formed from curved surfaces, let us derive the relationship between the object distance u and image distance v. Sign convention.
Formation due to convex mirror is, this is the convex mirror. If the object lies between from infinity to pole, where we keep object from here to here. Then we are getting the image between pole and focus. Pole and focus means inside the mirror. So the image is the size of the image is diminished image, means the size of the image is less than size of the object. Image forms between pole and focus, that the size of the image is very small. So what is the field of view? What is the field of view means it is a region between two extremal reflected rays is said to be field of view. Here the field of view is more for convex mirror. Field of view is more for convex mirror. So in a convex mirror, in this case we are all times we are getting here the image is erect image. The image is smaller than object. So that's why this case we are using in rear view mirrors. Rear view mirrors. Why we are using convex mirror as a rear view mirror means because of field of view of convex is more than concave and plane mirror.
Some sign conventions are used in this derivation. They are: the pole is used as the reference for measuring all distances. When the distance is measured in the direction of the incident ray, it is treated as positive. Otherwise, the distance is treated as negative. When the object and the image are above the principal axis, their height is treated as positive. Otherwise, their height is treated as negative. Derivation of the mirror formula. The incident ray emerges from point O and meets the spherical mirror at A at a height h. It gets reflected through the point I, which is also on the axis. The normal here is AC. The angle of incidence OAC and the angle of reflection CAI are equal and represented by theta. The line segment AP' is the perpendicular drawn from the point A to the axis. There are three right angle triangles thus formed. They are triangles AOP', ACP' and AIP'. Let the incident ray OA, normal AC and reflected ray AI make angles alpha, beta and gamma respectively. We know that sum of interior angles in a triangle is equal to the exterior angles. From triangle AOC, we have beta is equal to alpha plus theta. That is, theta is equal to beta minus alpha. From triangle ACI, gamma is equal to beta plus theta. By substituting theta is equal to beta minus alpha in the above equation, we have 2 beta is equal to alpha plus gamma. Equation 1. For simplicity, let us assume that h is very small, that is P' coincides with pole P. Then P'O is equal to PO, P'(C) is equal to PC, and P'(I) is equal to PI. And the angles alpha, beta and gamma are small enough to be treated as tan alpha, tan beta and tan gamma. Here, the values of tan alpha, tan beta and tan gamma are shown on screen. Substituting the values of alpha, beta and gamma in equation 1, we get equation 2. Substituting the values of PC, PO and PI and applying the sign convention in equation 2, we get the mirror formula whose calculations are shown on screen. The above formula relates the characteristics object distance U and image V respectively. The other characteristics, size of the object and the size of the image, are related by a quantity called magnification. Let us understand the magnification, that is the relationship between size of the object and the size of the image. Magnification. The image formed by a spherical mirror varies in size, but here we discuss the variation in height only. It is the ratio of the size of the image height to the size of the object height. Practically, m is equal to v by u. Let us consider an object OO dash. A ray coming from O dash is incident at pole P with an angle of incidence theta and get reflected with same angle theta. From the triangle POO dash, then tan theta is equal to OO dash by PO. Consider it has equation 1. From the triangle PII dash, tan theta is equal to II dash by PI. Consider it has equation 2. From equation 1 and 2, we get II dash by OO dash is equal to PI by PO. Consider it has equation 3. According to sign conversions, the object distance is minus u. Image distance is minus v. Height of the object is HO. Height of the image is minus HI. Substitute the above values in the equation 3. Then we get minus HI by HO is equal to minus V by minus U. Therefore, magnification m is equal to HI by HO, where HI is equal to height of the image, HO is equal to height of the object. In general, magnification can be defined as the ratio of the size of the image to the size of the object. That is, magnification m is equal to minus V by U. Numerical problem.
Magnification m equal to, it is a ratio of height of the image to height of the object. That equal to, it is a ratio of distance of the image that of distance of the object. So if m is equal to 1, m equal to 1 means height of the image is equal to height of the object, and distance of the image is equal to distance of the object. What is the image distance? What is the object distance? The distance between pole to object is said to be object distance. The distance between pole to image is said to be image distance. M is greater than 1. M is greater than 1 means height of the image is greater than height of the object. Distance of the image is greater than distance of the object. M is less than 1. Height of the image is less than height of the object, and distance of the image is less than distance of the object. M is positive. M is positive means image is virtual and erect. M is negative. M is negative means image is real and inverted. This is very important under 2 marks in SSC.
Problem. Application: making of solar cooker. We already learnt that a concave mirror focuses parallel sun rays at the focal point of the mirror. This same principle can be used in making the solar cooker. Make a wooden frame in the form of a TV dish. Cut 8 to 12 pieces of acrylic mirror sheets into isosceles triangles with their height equal radius of the wooden dish. Stick the mirrors to the dish with the bases of the triangles forming the circumference of the dish. Find the focal point of the solar cooker. Place the rice vessel at the focal point for cooking. In the case of a concave mirror, the rays very near to the principal axis will only get focused at the focal point. Other rays get focused at different points along the axis. This is spherical aberration.